So we are going to look at exponential functions today. Yesterday we did exponent laws, right? So we learned about how can we simplify something that has the same base, right? And then what did we do with the exponent? If we're multiplying them, if we're adding, if we're subtracting them, sorry, if we're multiplying them, if we're dividing them, or if we're power to the power. Now, we are going to look at exponential functions and its characteristics, like we did look at the quadratic function and its characteristics. But now we're going to look at exponential. So the first thing we're going to do is we're taking a piece of paper, right? Right here I have a piece of paper. And then that's how many faces do you see here? One side, right? So if I fold this piece of paper once, how many layers do you see now? So you see 2 layers, right? Good. So if I do fold this, right? If I fold that piece of paper once, you're seeing 2 layers, okay? How about if you fold it one more time? How many layers do you see now? 4. You have 1, 2, 3, 4. Fold time, how many layers do you see now? 8, right? Because you have the 1, 2, 3, 4, and then 1, 2, 3, 4, right? So I have 8. Fold it again. It's going to be 16 because 8 and 8, right? So that's, it's getting hard to fold even more. But if you fold it one more time, how many layers do you see? 32. If you fold it one more time, 64. So what do you see? What's happening here? They're doubling, right? It's doubling because I'm folding it in half, so it's making everything double. Okay, so we expect that to be what? 128? Yeah. And we expect that to be 56. And then that's going to be 512. And then 1024. Okay? Now, this is only by basically taking a piece of paper and then folding it in half.
You could fold the paper and you could get 124.
1,000. I wouldn't be able to, right? Okay, now we usually take the first difference to know if it's linear, right? We usually do the second difference to know if it's quadratic, right? So we're going to do exactly the same thing. Let's see if we can figure out if it's linear or quadratic. Okay, so if I do my first difference, so basically what I'm doing is I'm subtracting. 4 take away 2, so that's going to give me 2. 8 take away 4, 4. 16 take away 8, 32 take away 16, 64 take away 32, 128 take away 64, 256 take away 128, 512 take away 256, and then 1024 take away 512. Is the first difference constant? No. Okay, so it's not linear, we know that, right? All right, now let's check the second difference. Let's find the second difference. 4 take away 2, 8 take away 4, 16 take away 8, 32 take away 16, 64 take away 32, 128 take away 64, 256 take away 128, and then 512 take away 256. Is the second difference constant? No. So in this case, neither my first nor my second are constant. Okay? So it's not linear and it's not quadratic. Do you see anything special there?
Well, right here.
We don't know what the ratio is. That's right. So we're going to have to find that out. But looking at your numbers, do you see anything special?
Still doubling?
They're the same numbers, right? Yeah. If you look at the numbers for the first difference, they're the same as your number of layers, right? If you look at the numbers of the second difference, they're exactly the same as the number of layers. So it's repeating. So what does a ratio mean? What does the word ratio mean?
Ratio?
Contrast with what operation? It's not subtraction because subtraction is called difference. What would the ratio be?
Sum?
No, it would be called sum. It's division. It's division, okay? So to find the ratio, I divide. You see how when I'm finding first difference, I do y2 minus y1, right? With ratio, y2 divided by y1, okay? So when you're doing first ratio, you do y2 divided by y1. Okay? So let's find our ratio. 4 divided by 2 is 2. 8 divided by 4 is 2. 16 divided by 8 is 2. Actually, I'm doing it to the wrong column. I apologize. We should always do it to the y values, right? To these values right here, okay? So you go back to the y values and you do 4 divided by 2. So that's going to be 2. 8 divided by 4, that's going to be 2. 16 divided by 8, that's going to be 2. 32 divided by 16, 2. 64 divided by 32, 2. 128 over 64 is 2. 256 divided by 128 is 2. 512 divided by 256 is 2. And then 1024 divided by 512 is 2. Okay? So remember that with the division, you're going to have to do the number of layers. You're going to have to divide y2 over y1. So is my ratio constant? Yes, it is. My ratio is constant, and it's 2. Now, you guys told me something. What did you guys tell me? What's happening to my number of layers? It's doubling. Doubling means 2, right? Because it's doubling, I'm getting a ratio of 2. If it was tripling, what would be your ratio? 3. If it was quadrupling, it will be 4. What do you think your ratio would be if you're halving it? So if I take the piece of paper that I was getting, that I was folding, and instead of folding it into layers, I actually take it and rip it. So now you have half of a paper. Then you have a quarter of a paper, right? Then you have 1/8 of a paper, right? So what would be my ratio here? 1 divided by 2, it's a half. We call this half-life or half, right? So this is not our case here, right? But you have, the ratio could be a half, could be 1/4, could be 0.75, okay? It could be 2, it could be 3, it could be 1.25. So your ratio is how much you are increasing or decreasing by. What's the ratio that you're increasing or decreasing by? Okay, so we figured that the ratio is constant, right? The ratio is constant. That means you have what we call an exponential function. It's called exponential. So it doesn't grow at a constant rate. It grows at constant ratio. It grows slowly at first. As you see, it was growing slowly at first, but then it grows fast. Look at this. We went from 512 to 1,024. Okay? They're growing fast. At the beginning, 2, 4, 8, slowly. Then it shoots up. Okay? We call this exponential function. So I'm just going to write here we have a constant ratio. Okay? Now if we're going to graph this, I won't be able to graph all of it, but let's so I have the number of layers. And right here I have the number of folds. Okay, so if I have 1 fold, 2, 3, 4, 5, 6, I might not be able to fit all of them. So if I have 1 fold, I had 2. Two layers. If I had 0 folds, how many layers did I have with 0 folds?
1.
1, right? So I can include that here. So at 0, I have 1. At 2, I had 4. At 3, I had 8. At 4, I had 16. So if you look at this, it's going to look like this. Okay? Technically, it's going to look flat on the other side. And the reason why it's going to look flat on the negative side is if you think about it this way, and then in the negative, that means I'm ripping it, right? At the beginning, I start with 1 fold. When I rip it once, I have half a layer, right? If I rip it another time, I'll have quarter of a layer. If I rip it another time, I have 1/8 of a layer. If I rip it another time, it will be 1/16 of a layer, right? So 1/16 is 0.00 something, right? It's a small number, right? Rip it, I keep ripping it. I can keep ripping it until I get to a point that I can't rip it anymore, but I still have a piece of a paper, right? We can go microscopically then, and then keep dividing in half, right? You're gonna have some molecules in there. You're not gonna be able to see them without a microscope, but it never becomes 0. It never disappears totally, okay? You're gonna always have a piece of an atom or molecule or whatever inside. So that's why if you look at the end of this graph, it's going to be kind of getting closer and closer to the 0 line, but it will never touch that 0 line. Okay? The number is going to be like 0.00000000001, right? But it will never be 0. Okay? So an exponential function that we're going to get to, it's going to be flat on one side and increasing or decreasing on the other side. Okay? Are we okay with this? Okay. We've already kind of talked about this. So it's asking you to describe how the numbers of layers change as the number of fold increases. What did you guys answer for this? What happened to the number of layers? How did they change? They doubled. So doubles each time. When we calculated the first and second difference in the table, what did you notice? First and second difference, they're not constant, right? We also saw that they grow just like the y value, right? Right? We had the same number, 2, 4, 8, 12, right? 2, 4, 8, 16. Sorry. Yeah. We're talking about the first and second difference. So describe the x values for me. What's happening to the x values? The x values are what? 1, 2, 3, right? Right, which is they're increasing by 1. Okay. How about the y values? What's happening to the y values? Sorry? They're doubling. So they're multiple of 2, right? The pattern, they're multiplied by 2 each time. So let's think about these numbers, right? If they're multiplied by 2 each time, the first thing is going to be 2, right? Or 2 to the power of 1, right? And then for the second one, it's going to be 2 times 2. Then I'm going to multiply by 2 again, so that's 2 times 2 times 2. That's 2 times 2 times 2 times 2, right? How can I write this instead of writing it that's 2 times 2, 2 times 2 to the power of whatever, right? So that's going to be 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, right? And that depends on what the x value is. If the x value is 1, it's going to be 2 to the power of 1. If the x value is 2, it's going to be 2 to the power of 2. X is 3, 2 to the power of 3, yes? If I go back here, right? 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. 2 to the power of 4 is 16, right? So the x value is my exponent, right? And that's why it's called exponential. Whenever your letter or the variable is in the exponent, it's called exponential because the variable is up there. It's in the exponent, okay? So you see how in linear function, we used to write it like this. Y equals 2x plus 5, right? That's linear. In exponent, it was y equals 2x squared plus 3x plus 1, right? Where my exponent is 2, right? With exponential now, it will be more like 2 to the power of x. Your exponent is the variable, is the letter. Do we get that? Okay? So we calculated the common ratio, which is y2 over y1. And what did we get? We said that the first ratio is constant. And it was equal to 2. Are we good with that? All right. Now,
So that you roll first reticule. Is there more reticule, like 3?
we don't cover them here at all. Okay. Okay, so we're going to compare now. We're going to compare what we have learned so far. We've learned the linear, which we usually learn that in grade 10. We learned the quadratic here, and then we're learning exponential. Okay? So the linear equation looked like what? Y equals mx plus b. You remember that? It's a linear function. X doesn't have a degree. It's degree 1. We said it's a slope times x plus the y-intercept. In the table of values, what would be constant? First difference. And then how would your graph look like? Straight line. Quadratic relation, how would the equation look like? ax squared plus bx plus c, where your highest degree is 2, right? In the table of value, what would be different? What would be constant? And the graph is going to look like a parabola. With an exponential relation, your equation is going to look like this, where you have y equals a base, which is a number, to the power of x, okay? Or you can also have it look like this, y equals a number base to the power of x. So an example for this would be like y equal 2 to the power of x, where a is 3 in this case, okay? Your base is 2 to the power of x, okay? We'll talk about these as we go, okay? In the table of values, what is constant? First ratio is constant. And then the graph is going to look like this. So it's going to be one side almost horizontal. While the other is increasing or decreasing fast. It's either or. It will either grow fast or decay fast. No. Doesn't have to be. So this is growth. I know I can't do this. Okay. This will be the growth, and this would be a decay. Okay? Decay because it's decreasing fast and then it plateaus. So it's going to be either this one or that one. It can't be both. Okay? Oops. Okay, so let's look at the equations. So examine each equation, determine the type of relation it represents, linear, quadratic, or exponential. So if you look at the first one, it's negative 5 to the power of x. What kind of function is this? Exponential, and the reason for it? The variable is what? The variable is an exponent. Second one? Quadratic, and how do you know? And then the last one is linear and degree 1. Okay, so for this one, it's asking you to complete each table, determine whether the relationship is exponential, give a reason for your answer. So if we do this, so the first one, if you have x and then you have the y is 3 to the power of x, okay? We know it's going to be exponential because of the equation, it's 3 to the power of x, but let's do the table of values. So if I have 3 to the power of negative 2, what is that equal to?
Negative 9. 9.
Nasi? What is it? 1 over 9. Remember that 3 over to the power of negative 2, that's the same thing of 1 over 3 to the power of 2. Because if I have a negative exponent, I flip, right? Flip my base, make my exponent positive. So that's 1 over 9. Okay, 3 to the power of negative 1. 1 over 3. 3 to the power of 0. Anything to the power of 0 is 1. 3 to the power of 1. 3 to the power of 2. Okay. If I want to find the first ratio, what do I do?
Divide.
Okay, divide what by what?
The second or the first.
Okay.
And second.
So 1 over 3 divided by 1 over 9. What would be your answer for this? 3. Flip the second. Okay, so I'm going to show you how to do this. 1 over 3 divided by 1 over 9 is the same thing as writing 1 over 3 times, so I change the division to multiplication, and I flip my second fraction. So that's going to be 9 over 1. Right? So,
Could you also flip both
No.
fractions?
No.
In terms of negative?
No. Like you mean 3 to the power of negative 1 divided by 3 to the power of negative 2?
No, like, because they're already in a fraction, so couldn't you flip both of them? So it would be negative 3 over 1 divided by negative.
No. When you flip, it's only the exponent that becomes negative, not the number.
But there's no exponents in those fractions.
There is. It's 3 to the power of negative 2 and 3 to the power of negative 1. But let's not get into this.
But
No.
in the y value.
No. No, you can't flip and make them negative. If you flip, you make the exponent negative, not the number. Okay? No. Doesn't work that way. Be careful. Okay? So, I flip my second fraction. Now, how do I simplify this? How do you multiply fraction? Top by top?
Bottom by bottom.
Bottom by bottom. So that's 9 over 3. What's 9 over 3? 3, right? So 9 over 3, which is 3. So I know when I do y2 divided by y1, so 1/3 divided by 1/9, I'm going to get 3. So then I have 1 divided by 1/3. Again, flip, right? Make your division multiplication, your second fraction. 1 times 3, that's 3 over 1, that's still 3. Okay? So that's going to be 3. 3 divided by 1? 9 divided by 3? Okay, so exponential? Okay, determine whether the relationship is exponential. Yes. And the reason is because the ratio is constant. Okay, let's look at the second table. So my x's are -2, -1, 0, 1, 2. And then they gave me a function of a half to the power of x. I know is it exponential or no?
Yes.
Yes, because the exponent is a variable. I know that, but I have to show my work. Okay, 1/2 to the power of -2. What is that equal to? 2 to the power of 2. 1/2 to the power of -2. We know if we have a negative exponent, we flip the base, make the exponent positive. So flipping the base, that gives it 2 over 1 to the power of 2. 2 over 1 to the power of 2 is equal to 4. Yes? Good. A half to the power of -1. 2 to the power of 1, which is 2. How about half to the power of 0? How about half to the power of 1? How about half to the power of 2? 1 over 4. Do we know that? Do we know why? So a half to the power of 2. Remember, if I have this, the 2 goes for the 1, the 2 goes for the 2. 1 to the power of 2, that's 1. 2 to the power of 2, that's 4. Right? It's the quotient rule, whatever it's called. What is it called? Quotient rule, yeah. No, not quotient rule. It's called power of a quotient. That's what I meant. Okay, let's look at the first ratio. First ratio means I have to divide y2 divided by y1. So 2 divided by 4. Excuse me. It's a half. Thank you. 2 divided by 4. You have 2 pizzas. There's 4 people. They each get a half. 1 divided by 2. And I know that my ratio is going to be a half because my base is a half. Right? You guys have to catch these things. Right? You see? My ratio here is my base is 3. Right? My ratio is 3. In the previous one, my base was 2 and my ratio was 2. In this, my base is a half and my ratio is going to be a half. Right? It has to click there. All right, half divided by 1. 1/4 divided by a half. So 1/4 divided by a half. What do we do? Flip what? Don't tell me flip. Okay, so it's going to be 1/4 times 2 over 1. So it's going to be 2 over 4, which is a half. So again, this is exponential. Yes, it is. And the reason is because the first ratio is constant. Okay? So, we're going to look at this. I think the lesson would be done for now. So, examine each graph, determine the type of relation it represents, give a reason for your answer. First one? Why? Second one? So it is flat on one side and growth on the other.